My dear students, I am Sarpradeep. Welcome to our online class. We, all the teachers, are very sorry as due to pandemic COVID-19, we are not able to teach you properly in these days. But we, all the teachers, are ready 24 hours a day to help you and to clear all your doubt. And please don't hesitate to ask. So ask freely whenever you have any doubts. Dear students, safety first. So during this pandemic COVID-19, make sure to follow the SOP of COVID-19 and please don't waste your precious time. Utilize this time to improve yourself. Think this is a chance God has given to you to improve yourself. Make a daily timetable and follow it very strictly. Dear students, before we start our class, let me give you one mantra. This will help you to learn maths well. The mantra is, only regular practice will make you learn maths very well. So, be regular while learning mathematics. Class 8 Maths, Chapter number 1, Ratio Number. To learn ratio number, first, we need to understand what is natural number, whole number, and integers. In the previous class, we have learned about natural number, whole numbers, and integers. Let's remind once more. Natural number. Counting numbers are called natural numbers. Example 1, 2, 3, 4, 5, and so on. Next is whole numbers. If we added the number 0 to the collection of natural numbers, then these collective numbers are called whole numbers. Example 0, 1, 2, 3, 4, 5, so on. Next is integers. If we put the whole numbers and the negative numbers together, the new collection of numbers are called integers. Example, here the negative numbers are -1, -2, -3, and so on. And whole numbers are 0, 1, 2, 3, and so on. And this collection of numbers are called integers. Let me explain this in Manipuri. Natural numbers. Natural numbers haibasi akoina masing thibda sinariba number sibu natural number kawi. Masing thibda sinariba number si counting number haraga su khangnai. Example the 1, 2, 3, 4, 5, so on. Mathang si whole numbers. Whole number haibadi mapum moiba number haibadi masyata daba number. Mapum moiba number haibataragadi 0 na mangda laani aduga 1, 2, 3, 4, 5 sumay sumsakrani. Sidaita whole number laibasida natural number ki mamangda 0 si mamangda hapsan labadi whole number tare. Example the 0, 1, 2, 3, 4, 5, so on. Next is integers. Integer si negative integer ka whole number ga ani sigi collection tauba number apun badubu integer kawi. Negative integer da negative number da -1, -2, -3 sumsakre. Whole number da 0, 1, 2, 3 haina sumsakre. Sigi apun ba number sibu kari haina khangnage haibakanda integer hairaga khangnai. Now next is rational numbers. Definition. A rational number which can be written in the form p by q where p and q are integers and q is not equal to 0 is called a rational number. So in this rational number we can put the number in the form by p by q. Both p and q must be integer and the denominator q must not be equal to 0. Example, -7 by 5, 6 by 7, 5 by -9 are all rational. Here in this number -7 by 5, -7 is integer, 5 is an integer, so -7 by 5 is a rational number. In the second case, 6 by 7. 6 is an integer, 7 is integer, so 6 by 7 is in the form of p by q, so 6 by 7 is an rational number. And next is 5 by minus 9. In this 5 by minus 9, 5 is a rational number, 5 is an integer, and minus 9 is also an integer, so 5 by minus 9 is in the form of p by q, so 5 by minus 9 is also a rational number. Let me explain in Maitailon. Rational number haibasi p by q gi form da thamba yagadabani. P ga q ga si animak integer oigani, aduga denominator q si 0 oiba yade. Example da minus 7 by 5. Minus 7 by 5 ta minus 7 si integer ni, 5 su integer ni, aduna minus 7 by 5 si p by q ki form da laire, aduna minus 7 by 5 si rational number oire. 6 by 7 si su 6 si integer ni, 7 si integer ni, 6 by 7 si p by q ki form da laire, aduna 6 by 7 si rational number ni. 5 by minus 9. 5 si integer ni, minus 9 si integer ni, 5 by minus 9 si p by q ki form da laire, aduna 5 by minus 9 si su rational number ama oire. Next is properties of rational number. The first one is closure property. In this closure property, 4 properties are there. The first one is closure property of addition, and the second one is closure property of subtraction, and the third one is closure property of multiplication, and the fourth one is closure property of division. Now the first one, closure property of addition. For any two rational a and b, a plus b is also a rational number. Here this closure property of addition says that if we take any two rational number and if we add the two rational numbers, if the result is again a rational number, then it says that rational number is closed under addition. Example, 2 by 5 plus 1 by 5 is equal to 5 and 5 are taking LCM, then we are getting 5. Then in the numerator 2 plus 1 is coming, then 2 plus 1 are add together, then we are getting 3, then the denominator is 5. Then we know that 3 by 5 is in the form of p by q, so 3 by 5 is a rational number. So when we add any two rational number, we are getting a rational number. So this satisfies the closure property of addition. Subtraction. For any two rational number, subtraction. For any two rational numbers a and b, a minus b is a rational number. This property is almost same as addition. If we take any two rational number, if we subtract the two rational numbers and the result is a rational number, then this satisfies closure property of subtraction. Example, for any two rational numbers 3 by 5 and 1 by 5, we know 3 by 5 minus 1 by 5 is equal to 3 minus 1 by 5. Then if we subtract these two, we are getting 2 by 5, and which is also a rational number. This 2 by 5 is also a rational number. So it says that rational number are closed under subtraction. Next is multiplication. For any two rational numbers a and b, a into b is also a rational number. If we take any two rational numbers, if we multiply the two rational number, then the result is a rational number. Then it says that rational numbers are closed under multiplication. Example, for any two rational numbers 2 by 5 and 2 by 3, we know 2 by 5 into 2 by 3 is equal to, if 2 and 2 are multiplied, then we are getting 4. 5 and 3 are multiplied, then we are getting 15. We know that 4 by 15 is also a rational number. Then we can say that rational numbers are closed under multiplication. Now, division. Rational numbers are not closed under division. This means that if we take any two rational number and if we divide the two rational number, the resulting number is not a rational number. Example, for any two rational numbers 2 by 5 and 0, we know 2 by 5 divided by 0 is equal to 2 by 5. If this divide is changed into multiply, then this 0 in the denominator there is number 1. If 0 and 1 are interchanged, then the number becomes 1 by 0. Then 2 times 1 is 2, 5 into 0 is 0, then we are getting 0. Actually 2 by 0 is undefined since 2 cannot divide by 0. So 2 by 0 is not a rational number. So we can say that rational numbers are not closed under division. Let me explain in Manipuri. Properties of rational numbers. Properties of rational number the first the closure property lai. Closure property the property mari lai. Ahambagi sina closure property of addition. Second kina closure property of subtraction. Third dana closure property of multiplication. Mari subadana closure property of division. First ki hanalage closure property of addition. Closure property of addition haisi any two rational number ani lauraga akoina plus tauraga taraiba number du rational number oigani haba. Example the 2 by 5 si rational number ni, 1 by 5 si rational number ni, rational number ani si plus taurakanda 3 by 5 tare, 3 by 5 si rational number ni, aduna rational numbers are closed under addition si summe. Mathangda subtraction lae, subtraction su mamangi addition to samane. Akoina loaning ba rational number ani lauraga rational number ani du minus to bakanda rational number tagani haba. Example da akoina 3 by 5 ka 1 by 5 ka rational number ani si laure. Rational number ani si minus to pada 2 by 5 tare, 2 by 5 si rational number ni. Adu itargati rational numbers are closed under subtraction si summe. Mathangda multiplication lae, multiplication si su samane. Multiplication dana multiply sinar pani. Multiplication dana loaning ba rational number ani laure. Rational number ani du multiply toraga taraiba number du rational number oigani haba. Example da any two rational number 2 by 5 ka 2 by 3 ka laure ani si multiply toksanare 4 by 15 tare, 4 by 15 si rational number ama oire. Aduna rational numbers are closed under multiplication si summe. Mathang da division lae. Division da haisi any rational number ani multiply toksanaba kanda taraiba number du rational number oiroi haba. Sida haisi rational numbers are not closed I say under division. Rational number C division da close oide haibani. Example da any two rational number ani laure 2 by 5 ka 0 ka laure 2 by 5 ka 0 ka si divide tokthonare. Divide on bakanda sigi multiply si sida laiba divide si akoina multiply on bataragadi 0 gi makhada haibadi denominator da 1 lay 0 ga 1 ga du interchange tawna tardi 1 by 0 la ani 2 by 5 into 1 by 0 si 2 ꯒ 1 ꯒ multiply ꯇꯧꯕꯗ 2 ꯇꯥꯔꯦ 5 ꯒ 0 ꯒ multiply ꯇꯧꯕꯗ 0 ꯇꯥꯔꯦ 0 ꯅ 2 ꯗ divide ꯇꯧꯕ ꯌꯥꯗꯦ ꯁꯤ undefined ꯅꯤ ꯄꯨꯊꯣꯛꯄ ꯉꯝꯗꯦ aduna 2 by 0 si rational number taraktre aduna ngasai closure property si division dadi sumde haiba haibadi rational numbers are not close under division. Next is commutativity. Commutativity dasu property mari laigani commutativity of addition second commutativity of subtraction and third is commutativity of multiplication and the fourth one is commutativity of division. The first one is addition. For any two rational numbers a and b, a plus b is equal to b plus a. Here this commutativity of addition says that if we take any two rational numbers and if the order of the two rational numbers are same and if we add together, if both the values are equal, then we can say that rational numbers are commutative under addition. Here we note that a plus b is equal to b plus a. In this a plus b, a is written first and b is written second. If the order are changing, then here b comes first and a second. So the order of a and b are interchanged and we are adding together. And if both the answers are equal, that means a plus b and b plus a, their answers are equal. Then we can say that rational numbers are close. Rational numbers are commutative under addition. Example. For any two rational numbers minus 3 by 5 and 1 by 5, we get minus 3 by 5 plus 1 by 5 is equal to minus 3 plus 1 by 5 is equal to minus 2 by 5. And 1 by 5 plus minus 3 by 5 is equal to 1 minus 3 by 5 is equal to minus 2 by 5. Here in the first case this minus 3 by 5 and 1 by 5 are adding together. Here I'm writing minus 3 by 5 first and 1 by 5 second, and here we get the answer as minus 2 by 5. And in the second case 1 by 5 is written first and minus 3 by 5 is written in second. After we are adding these two numbers together, we are getting minus 2 by 5, and we see that both the answers are equal. So minus 3 by 5 plus 1 by 5 is equal to 1 by 5 plus minus 3 by 5. Hence addition is commutative for rational numbers. Next is subtraction. Subtraction is not commutative for rational numbers. That is, for any two rational numbers a and b, a minus b is not equal to b minus a. Example, for any two rational numbers 4 by 5 and 1 by 5, we get 4 by 5 minus 1 by 5 is equal to 4 minus 1 by 5 is equal to 3 by 5. Here, if we want to subtract 4 by 5 and 1 by 5, 5 and 5 are taking LCM, then we will get 5. Then this 5 is dividing this 5, then we are getting 1. 1 multiply 4, 1 times 4 is 4, 4 is getting, this minus 1 comes here, then 5 is dividing by 5, then we are getting 1, 1 times 1 is 1. If we subtract these two, we are getting 3, so 3 by 5 is getting. And Now this 4 by 5 and 1 by 5 are changed their order. Then means 1 by 5 comes first, then 4 by 5 is second. And if we want to subtract these two, taking LCM of 5 and 5, that is 5. Then 1 minus 4 is coming. If we subtract 1 minus 4, then the answer is minus 3 by 5. Here we see that this is 3 by 5 and this is minus 3 by 5. So both the answers are not equal. So 4 by 5 minus 1 by 5 is not equal to 1 by 5 minus 4 by 5. Therefore, subtraction is not commutative for rational number. Next is multiplication. Multiplication is commutative for rational number. For example, for any two rational numbers 2 by 5 and minus 3 by 7, 2 by 5 into minus 3 by 7 is equal to, if 2 and minus 3 are multiplied, then we are getting minus 6. 5 and 7 are multiplied, then we are getting 35. And if 2 by 5 and minus 3 by 7, if we change their order, minus 3 by 7 comes first, 2 by 5 comes in second. If we want to multiply these two, minus 3 into 2 is minus 6, 5 into 7 is 35. Here we see both the answers are equal. So 2 by 5 into minus 3 by 7 is equal to minus 3 by 7 into 2 by 5. Since both these two answers are equal, we can say that multiplication is commutative for rational numbers. Division. Division is not commutative for rational numbers. For example, for any for any two rational numbers 3 by 5 and 9 by 10, we are taking any two rational number to 3 by 5 and 9 by 10. Here, the first number 3 by 5 is dividing by 9 by 10. Here, this divide is changed into multiply, then 9 by 10 is changed their place. So 10 will come up and 9 will come down. So we are getting 3 by 5 into 10 by 9. 5 divide 10, then we are getting 2, and this 3 divide 9, then we are getting 3. 3 divide 3 1 times, then 1 times 2 is 2, 1 times 3 is 3. So we are getting 2 by 3. And in the second case, 3 by 5 and 9 by 10 are changed their order. Then 9 by 10 comes first, 3 by 5 comes second, and if we divide these two, first this divide is changing into multiply, then we are getting this 9 by 10 here, divide is changed into multiply, 3 by 5 are interchanged their place, then 5 by 3 is coming. 9 and 3 we can divide by 3. 3 divide 3 we are getting 1 times. 9 divided by 3 we are getting 3. 5 divided by 5 getting 1 times. 10 dividing by 5, then we are getting 2. 5 2 times is 10. Then 3 times 1 is 3, 2 times 1 is 2. Then we are getting 3 by 2. We see that here the answer is 2 by 3, and in this case we are getting the answer is 3 by 2. So here the two answers are different. So this first one is not equal to the second one. We know these numbers are coming here. 3 by 5 divided by 9 by 10 is equal to 9 by 10 is divided by 3 by 5. These two are not equal, since 2 by 3 is not equal to 3 by 2. Therefore, division is not commutative for rational numbers. Let me explain in Maitalon. Commutativity. Masigi commutativity ki property sida property mari laini, commutativity of addition haibama, commutativity of subtraction haibama, commutativity of multiplication haibama, commutativity of division haibama. Ahambagida commutativity of addition lae state haisi addition da haisi addition haibadi plus haibani akoi any two rational number laure aduga rational number ani du plus tore aduga ngasai ki logi ba rational number ani du ki order du change tawthonare haibadi ahambada a plus b irambasi order haibadi moi gi laibam du change tawthonaraga b plus a na thame sigi ani sigi magi value si samanna tarpa taragadi adu boy koina kari kauki hai kanda rational numbers are commutative under addition haigani hauji kanote yengsi example da rational number ani lore -3/5 haiba mane 1/5 haiba mane hauji sigi lori ba rational number ani si plus tore -3/5 plus 1/5 ani si plus tore matung da -2/5 tar e mathang da ngasai gi number du gi order change tawthonare 1/5 plus -3/5 hain la e ani si plus to bada -2/5 tare ahambada tagiba number du ka sigi -2/5 siga manare adu itargadi -3/5 plus 1/5 siga 1/5 plus -3/5 siga manare adu itardi akoin sumaina haiba yare hence addition is commutative for rational numbers mathang da subtraction gi lae subtraction da di koina minus laurani ngasagi plus to gi bidu ka samane sida mo har sina learning ba rational number ani laure aduga rational number ani du minus tawnare aduga ngasagi logriba number ani du order change tawthoknaraga order change tawthar bai badi leibam du hongdokna ba aduga ani du amu minus obaduga manaba taragana ngasagi rational number si subtraction da commutative oi haina haigadoba adu sigi matang da di manati haiba subtraction da di manati haiba subtraction is not commutative for rational numbers haise adu sidai da any two rational number laure a minus b ga b minus a ga ani si manaro haiba example da any two rational number 4/5 ka 1/5 ka si laure 4/5 minus 1/5 si minus tawra matung da 3/5 tare 4/5 ka 1/5 ka si order change tawthoknare 1/5 minus 4/5 lai ani si subtraction tawra matung da -3/5 tare sigi tara iba answer ani si manadre amana 3/5 ni amana minus sign yawi -3/5 ni ani si manadrabnina akoina sumaina iba yare 4/5 minus 1/5 is not equal to 1/5 minus 4/5 hain iba yare therefore subtraction is not commutative for rational number hairani mathang da multiplication multiplication tadi amo ngasai ki commutative to sumi hairani state harise multiplication is commutative for rational number sida any two rational number ani laure ani si sida multiplication hai tardi multiply lakani rational number ani si multiply tawre -6/35 tare hojik 2/5 ka -3/7 ngasi order change tawthoknare -3/7 amana 2/5 lae ani si multiply tawra matung da -6/35 lae ani si ki answer si manare -6/35 -6/35 ani si manare aduna 2/5 into -3/7 is equal to -3/7 into 2/5 lae aduna sigisi summe therefore multiplication is commutative for rational number division tadi among asagi commutative property to sumaroi sida harise division is not sida not harise not commutative for rational numbers hauji example the learning ba rational number ni laure 3/5 haibam ga 9/10 haibam amaga laure ani si divide tauthonare 2 by 3 tare 2 by 5 ka 9 by 10 ka si order change tauthonare 9 by 10 na hana ire 3 by 5 na second lae ani si divide tauthonare matungda 3 by 2 lae answer ani si manaraktre amana 2 by 3 ni amana 3 by 2 ni manadrabadina 3 by 5 is not equal to 9 by 10 is not equal to 9 by 10 divided by 3 by 5 silani aduna hauji commutative property to sumde harani. Therefore division is not commutative for rational number.